am Dr. Ramanuja, working as an assistant professor in Department of Mathematics, Marri Laxman Reddy Institute of Technology and Management, Dundigal, Hyderabad. I hope in the previous module I discussed about special functions and also theorems like a Lagrange's mean value theorem and Cauchy's mean value theorem and expansions like a Taylor series expansion. I hope you enjoyed my class. Further, I am continuing the one more topic which is called as partial differentiation, which will comes under the multivariable calculus. For this course, I am referring the textbooks like Higher Engineering Mathematics by B.S. Gravel, and also some parts I am referring J.K. Jain, and also some parts I am referring S. Chan textbook. This is about my introduction. In this module, I am going to cover, this is the multivariable, in this module, I am going to cover first one, which is partial differentiation. What is meant by partial differentiation? How can we calculate the partial differentiation for the implicit functions as well, implicit function. Further, I can extend Euler's theorem for the function. How can we evaluate the given like a trigonometric functions or exponential functions? How do you apply the Euler's theorem for the function? And also third module, I am going to cover like a transformations of the functions using the Jacobian, where how the functions are dependent, how the functions are independent, the relation between the dependent functions and independent functions. Further, using this partial differentiation, we are going to calculate this is the main application of the multivariable calculus for the determination of the maxima value and minima value for the two variable function. Further, we are extending into the three variable function, which is called as a Lagrange's multiplier method. These are the 5 module I am going to cover multivariable calculus. Okay, let us go with their definition of the partial differentiation, and also how do you calculate, what is the difference between ordinary differentiation and partial differentiation. Let me talk about, before going to the partial differentiation, let me talk about what is meant by dependent variable, what is meant by independent variable, what is single independent variable, what is two independent variable, what is three independent variable. Let us take the function. Let us take a function. Function is f of x. This is called as a single variable function. X is the independent variable, y is called as a dependent variable. Further, I am extending into two variable function. Let us take u. U is a function of x comma y. This is a function of two variables x and y. Further, there are two independent variables. Let me talk about the three variables x, y, z. This is f is a function of three variables x, y as well as z. They are called as independent variables. Let me talk about one more function. U is a function of x, y, z and time function. What is the main motive of these functions we are observing? When I wrote first the function, which is single independent variable function, one dependent variable function. If you look the second function, two independent variables, one is the dependent variable, here you have three independent variables, and further I am extending into the 4. Further, we can extend for n independent variables, because when we go for the higher level, we are going to treat as so many independent variables to identify the variation of one function with other function. Okay, already you familiarized by the derivatives. I hope all the derivatives what you studied in the previous classes, like a derivative of x power n, derivative of constant, derivative of log x, derivative of e power x. These are all basic concepts of the differentiation formulas. And also we are extending into the partial differentiation. If this word itself, it shows partially. When we take the functions, suppose the function having two variables, we are treating one function is a dependent function, other function we are treating as an independent constant function. Such a case, we are going to apply only partial differentiation. Let us take about the, if you take the rectangle, if you take this rectangle, there is a length and width. See, if I am increasing the length, there is no change in their width. Are you observing now? If you see, if I want to increase the width, both sides will be increased, whereas the length will not get any change. That's a, here one quantity we are varying, we are treating as a other variable as a constant. Now you idea about what is the dependent, what is independent. I can say it is a constant. See, in another form, partial derivative, where it holds that independent variable as a treat it as a constant. Whenever we are treating the two variables, let us take a. A is equal to what? Length times width. I can vary only length. I am going to treat it as width as a constant. This is a two variable function. Let us take area is a function of L and W. If I take this volume is a function of L, B and H. If you see this length and breadth and height, how many independent variable? There are three independent variable for this function. If I want to measure length, there will be breadth and height will be a constant. Suppose if I want to vary B, if I want to vary the B, L and H as a treat it as a constant. That is the main concept of the partial differentiation. If you take the ordinary differentiation, there will be two quantities are dependent quantities. Okay, I hope now it is clear about partial. Partially means one variable when we are varying, we are treating as other variable as a constant. This is the main concept of the partial differentiation. Okay, let us go with there. How do you calculate the partial derivatives of the function? Let us take the function. Z is a function of two variables x and y. We are treating. Let us take this as a function. Z is a function of x and y. Here x and y are the independent variables. X and y are the independent variable. Z is the dependent variable. When we make the partial derivative with respect to x, this becomes, we are treating y as what? Y as a treated as constant. We are treating y as a constant. That's what we are going to write. This is nothing but what? Dou f by dou x, which is equal to limit delta h tends to 0, f of x plus h comma y minus f of x comma y divided by h. I can say this is zx. Partial derivative with respect to x. What we treat it as? X as a constant. Similarly, the equation 1, if I write the partial derivative with respect to y, treat it x as a constant, dou f by dou y or fy or zy. This equation, we are making the partial derivative with respect to x, limit delta h tends to 0, f of x comma y comma y plus h minus f of x comma y divided by h. This is called as partial derivative with respect to x and with respect to y. Suppose this function, this is called as a dou z by dou x or dou z by dou y or dou f by dou x, which is called as first order partial derivatives. Further, we are extending first order partial derivative into second order partial derivatives also. We can extend the, we can say this such a functions are called as higher order partial derivatives. Let us look this, how do you calculate the second order partial derivative? Let us take this function, z is a function. Already we calculated the derivative with respect to x. It becomes what? Dou f by dou x, limit delta x tends to 0, f of x plus h comma y minus f of x comma y divided by h. This is first order derivative. Let us assume this is equation maybe 3. Suppose if I make the equation 2 partial derivative with respect to x, I will do again. Which function I am going to treat as a y as a constant. Therefore, it becomes zxx or fxx, which is dou square f by dou x square. We are calculating one more derivative for the equation number 2. Then it becomes limit h tends to 0 fx. What is meant by fx? Already that function we calculated one derivative which represent fx. That function we are taking as f of x plus h comma y minus fx x comma y divided by h. This is called as second order partial derivative with respect to x. Similarly, equation 3, Similarly, equation 3, I can calculate the partial derivative with respect to y. This is called as second order partial derivative. We know about first, what is meant by first order partial derivative, dou z by dou x and dou z by dou y and dou square f by dou x square, which is called as second order partial derivative. Similarly, if I take the equation 3, I can do partial derivative with respect to y. If I do partial derivative with respect to y, it becomes fyy. I can say, you can rewrite dou square f by dou y square limit h tends to 0 f of y, f of x comma y plus h minus fy x comma y divided by h. This is called second order partial derivative with respect to x. This is very simple concept. We can take first order partial derivative. You do one more derivative with respect to x, which gives dou square f by dou x square, which is called a second order partial derivative. We can say these are all, when we come across with the second order and third order, we can say higher order partial derivative. Similarly, let us take this equation 2. I can calculate partial derivative with respect to y also possible. Suppose this, it must remains the function in terms of y, which is dou y dou x, which is dou square f by dou y dou x. Already we calculated equation number 2. I am going to calculate partial derivative with respect to y. Therefore, limit delta h tends to 0 fx x comma y plus h minus fx x comma y divided by h. This is also called as second order partial derivative with respect to dou square f by dou x, dou square f by dou y and dou x. Further, we can calculate similarly equation 3. When we calculate the partial derivative with respect to x, then this becomes zxy, which is dou square f by dou x dou y limit delta h tends to 0 dou fy x comma x plus h comma y minus fy x comma y divided by h. These are called higher order partial derivative. When we calculated the first order derivative, further we are extending into second order as well as the third order partial derivatives. We say that such a functions are called higher order partial derivative. Look, the first already, what is higher order partial derivatives? Let us take the higher order partial derivative. Suppose this already dou z by dou x, we know this is the first order. When we calculated one more order of the derivative of this function, it becomes dou square z by dou x square. I can say simply fxx. Some notation they are going to write as zxx. Okay, zx is nothing but second order partial derivative with respect to x. Already, first we need to calculate which derivative? Dou z by dou x. That you must understand the concept of derivative. First we need to calculate partial derivative with respect to x. Again, further we need to calculate partial derivative with respect to x. Here, second way, we calculated dou z by dou x. Further, we are extending derivative, we are going to calculate with respect to y. It must remain some function of y. Then only we are going to calculate dou by dou y. Therefore, dou square z by dou y dou x, which is nothing but fxy. See, whatever we calculate the higher order derivatives, already at least one first order derivative must be existed. Further, we need to calculate higher order derivative, at least some function must be remains. Then only we can calculate the higher order partial derivatives. Okay, let us go with the one more concept. See, this is dou square z by dou x dou y. There is a one partial second order partial derivative. How do you write the notation? This is very important notation. Most of the time we will get confused. How do you write this one? Dou by dou x of dou z by dou y. First we need to calculate with respect to what? With respect to y. Again, partial derivative with respect to x. Then only this becomes dou square z by dou x dou y. See, one more derivative, dou square z by dou y dou x. How do you write this one? Dou by dou y of dou square dou z by dou x. We need to calculate first order partial derivative with respect to x. Again we need to calculate dou z by dou y, then only these two conditions are exist. Most of the times dou square z by dou x dou y equal to dou square z by dou y dou x. These are the mixed second order partial derivatives. Okay, see, why to study partial derivatives? Because most of the times civil engineering and mechanical engineering and electrical engineering and EC, electronics and communication engineering, most of the times a partial differential equations will be present. How these partial differential equations are exist, we will see with an examples. Okay, let us look this equation. We are saying that Laplacian equation. Okay, Laplacian equation. If I write the Laplacian equation, del square u equal to 0. Most of the times we are identifying the Laplacian equation. Any particle is moves around any nucleus in the form of the wave propagation. We need to verify the del square u. See, how do you expand the del square u? Dou square u by dou x square, dou square u by dou y square equal to 0. This is nothing but a second order partial derivatives. Laplacian equation is a second order partial. We can extend into three variable function also. Okay, this is a Laplacian equation. Del square phi equal to 0. Come to the one more equation which is called as a heat conduction equation. This is for this heat conduction equation. For the first heat conduction equation, dou T by dou T is equal to C into dou square T by dou x square. See, here the time is the dependent variable, x is the independent variable, here T is the independent variable, time is the independent variable, where C is a constant. This is also a mixed second order as well as the first order equation. Come to the next wave propagation, because we can say further we are extending into the wave equation vibrating functions. Let us take dou square u by dou t square, C into dou square u by dou x square, dou square u by dou y square. These are all the partially in any equation. First we need to concept about in any of these equations there will be some partial derivative existed. When we say the partial derivative, you must identify what is the dependent variable, what is the independent variable. Further, we can extend the whatever the concepts are occurring, either Laplacian equation or heat conduction equation or a continuity equation. Most we studied about the continuity equation del u equal to 0. In this continuity equation, most of the times partial derivatives are involving to measure one variable as a treat it as a constant, other variable as a dependent variable to calculate the some wave functions. Okay. Further, I am going to take small example problem for this module. How do you calculate the first order derivatives and second order derivatives for the function? Okay. Let us go with an example problem. Find the first order and second order partial derivatives of the function z equal to x square y square minus 3a xy. See here, see how do you write the function? This is the first notation we must get the clarity for the function. See, I can say z is a function of how many variables we need to must know. How many variables? Two variables. One is x, one is y. Let us write this equation is x square plus y square minus 3a xy. This is the equation you must understand. And there is some constant is present. That constant is called as a. Okay, let us write this function in terms of x square y square minus 3a xy equation 1. For this equation 1, I can make there are two independent variables are involved. One is x is a independent variable, y is also independent variable, z is the dependent variable. I can calculate the partial derivative with respect to x and with respect to y. Okay, let me talk about the first order partial derivative. Equation 1, partial derivative with respect to x I can find. What happens with respect to x? This becomes dou z by dou x. Some notation, they may write zx. If I calculate the derivative of x square, you know, familiarized by derivative of x power n. What is x power n derivative? N into x power n minus 1. Similarly, x square derivative becomes 2x. And when we make the partial derivative with respect to x, y as a treat it as a constant. We know the derivative of the constant. Derivative of the constant is 0. Therefore, y square term becomes 0. And similarly, there is a term called as x. Derivative of x is 1. This becomes 3ay. This becomes 3ay. Suppose I need to calculate the second order partial derivative. For this equation, again partial derivative with respect to x, this becomes dou square z by dou x. I can dou x square, I can write dou by dou x of dou z by dou x, which is nothing but zxx. I need to calculate one more derivative with respect to what? X. X square becomes, x derivative becomes 1. Therefore, the resultant value is 2. Okay. Similarly, I can calculate second order partial derivative with respect to y. Similarly, partial derivative with respect to x. Okay. Equation 1, partial derivative with respect to y. What happens? This becomes dou z by dou y, which is zy. What happens? X square becomes constant. What is y square derivative? It becomes 2y. Again there is a y becomes 1, it becomes minus 3ax. Again this equation, partial derivative with respect to y, it becomes dou square z by dou y square zyy, then this becomes 2. Okay. Now, what we observe from this result, we calculated the first order and also second order partial derivative with respect to x and y. I must know how do you, what happened in the case of dou square z by dou x dou y and also dou square z by dou y dou x. See, how do you write this? First of all, this equation. First, we need to calculate what? Partial derivative with respect to y. Let us write this equation dou square z by dou x dou y. How do you write this one? Dou by dou x of dou z by dou y. If I write this one, dou by dou x, already we know dou z by dou x. What is dou z by dou x? I got it. 2y minus 3ax. I need to calculate partial derivative with respect to x, then this becomes minus 3a. In the similar manner, dou square z by dou y dou x. What happens? Dou by dou y of dou z by dou x. What happens? This becomes dou by dou y of dou z by dou x. What is dou z by dou x? Already we got dou z by dou x equal to 2x minus 3ay. What happens? Now, in this case, if I make the partial derivative with respect to y, then this becomes minus 3a. Therefore, what is your conclusion? We got dou square z by dou x dou y equal to dou square z by dou y dou x. Now, these two quantities are equal. So, this also a mixed second order partial derivatives. I hope now it is clear about how do we calculate the first order derivatives and second order derivatives and also mixed second order partial derivatives. Okay, we'll go with some more problem. How do you evaluate the partial derivative with the help of the three variable function in the form of a logarithmic function. Okay, let us go with this problem. U equal to log of x square plus y square plus z square. Then we need to prove x square plus y square plus z square into dou square u by dou x square, dou square u by dou y square, dou square u by dou z square. The resultant value becomes 1. There is a proof. We need to calculate, we need to focus on this one. What we observe from this quantities, we need to calculate second order partial derivative with respect to x. And again similarly partial derivative with respect to y, second order derivative. Similarly second order partial derivative with respect to z. Then we add together, then multiply with the resultant value of x square plus y square plus z square, then the resultant becomes 1. Okay, let us go with the, already you know what are the dependent variables. How do you write the function? First of all, you must get the clarity. What is the u is a function of x, y, z, therefore which is log of x square plus y square plus z square. See, u is a function of three variables three are independent variables x, y and z. Let us write this u equal to log of x square plus y square plus z square. Let it treat it this an equation 1. Let the equation 1 partial derivative with respect to x. What happens? This becomes dou u by dou x. Derivative of log x already familiarized. What is the derivative of log x? Derivative of log x equal to 1 by x. Similar manner, the derivative of log x becomes 1 by x nothing but x square plus y square plus z square. Okay, log x derivative is 1 by x. Still there is a partial derivative. There is a partial derivative, inner derivative of the function, which is x square plus y square plus z square. We need to calculate what happens. We need only x derivative. Y is a constant, z is a constant. Then this becomes 2x divided by x square plus y square plus z square. Therefore, which is dou u by dou x. Similarly, still we need to calculate second order derivative, equation 2. We need to calculate one more derivative, equation 2, partial derivative with respect to x again. What happens? Dou square u by dou x square. I hope now it is clear. Derivative of this function is not like a previous function. This is in the form of u by v rule. Let me write the derivative. How do you write the partial u by v rule? D by dx of u by v, which is nothing but v square v into derivative of u minus u into derivative of v. Okay. Now I can treat this function. The denominator becomes what happens? X square y square z square. Okay. Now this becomes what? Whole square. Then this becomes x square y square z square whole square. Derivative with respect to what? 2x minus 2x into partial derivative of what? X square y square z square. Now look this derivative, dou square u by dou x square. This becomes, the denominator becomes what? X square y square z square whole square. Already this one is u and this one is v. Derivative with respect to x. How much it becomes? 2x. The remaining is 2. Then if you multiply with these 2, this becomes 2x square, 2y square, 2z square minus of 2x into derivative with respect to x. Then again it becomes here also 2x. Now if I simplify this one, 2x square, 2y square, 2z square minus 4x square divided by x square, y square, z square whole square. Then this I can rewrite in terms of this value. This is nothing but 2y square, 2z square minus 2x square whole divided by x square plus y square plus z square whole square. This is nothing but what? Dou square u by dou x square. See, now similarly, already we calculated what? Dou square u by dou x square with two partial derivative with respect to x. Similarly, I can write this one dou square u by dou y square. No need to calculate. Similarly, we can write like this. What happens? This becomes x square, y square, z square whole square. It becomes 2x square, 2z square minus 2y square. Similarly, dou square u by dou z square is equal to Similarly, dou square u by dou z square is equal to, how do you write this one? This becomes, denominator is x square, y square, z square, whole square. This becomes 2x square, 2y square, 2z square. Let us assume this may be equation number 3, this may be equation number 4, this may be equation number 5. First, what we got? We got dou square u by dou x square. Second, what we got? Dou square u by dou y square. Similarly, dou square u by dou z square. We need to add all these three quantities. Dou square u by dou x square, dou square u by dou y square, dou square u by dou z square. When you observe all this function, denominator value, right hand side values, always the same. What is the denominator value? Always x square, y square, z square, whole square. Then this becomes, what is the numerator? It becomes 2y square, 2z square minus 2x square plus, if you take next, 2x square minus, plus 2z square minus 2y square plus 2x square plus 2y square minus 2z square. If I simplify this one, what will be gets cancelled? Y square gets cancelled, plus x square plus z square minus z square. What will be the remaining numerator? Becomes 2 common, x square, y square, z square whole divided by x square plus y square plus z square whole square. This one term, this also gets cancelled. What will be the remaining? 2 by x square plus y square plus z square. Now, we find out all these three quantities. Still, we need to multiply with this x square plus y square. Now, I can write x square, y square, z square into dou square u by dou x square, dou square u by dou y square, dou square u by dou z square. The resultant value becomes x square plus y square plus z square into, what is this value we got? 2 by x square plus y square plus z square. Then this will be gets cancelled. The resultant value becomes 2. Now, I hope now it is clear about how to find the partial derivative with respect to xx and also how to find the partial derivative with respect to yy. Again, how to find the partial derivative with respect to zz. Okay. Now, this is the 3 variable function we taken as a logarithmic function, which is log of x square plus y square plus z square. Further, we will move one more function, which is also an important derivative of this function. Let us look this function. In this function, there is a resultant values are given. We need to verify both sides, LHS value as well as the RHS of the function. If z into x plus y equal to x square plus y square, then we need to show that dou z by dou x minus dou z by dou y equal to 4 into 1 minus dou z by dou x minus dou z by dou y. We need to verify both the results, how whether there is a partial derivative, first order partial derivatives are equal or not. Okay. Let me write function first of all, z equal to what? X square plus y square divided by x plus y. See here, the z is a function of 2 variables. Okay. Now, how do we write this function? Z equal to x square plus y square whole divided by x plus y. Let us assume this is a standard function z. We need to calculate first order partial derivatives with respect to x and with respect to y. Further, we need to, whatever we need, whether it is addition or subtraction or whether we need to substitute in the function, this is a similar procedure. See, if I calculate the partial derivative with respect to x. Already you familiarized by the partial derivatives of u by v. Okay, what is the derivatives of u by v? Then v square, v into partial derivative with respect to u, u into partial derivative with respect to v. These are the derivatives. Let us assume this one is u, the denominator quantity is v. Therefore, dou z by dou x is equal to the dou, which is equal to, denominator becomes x plus y whole square. How do you write this one? X plus y partial derivative with respect to x, partial derivative with respect to x, x square plus y square minus x square plus y square into partial derivative with respect to x, x plus y. Now, if I simplify this value, this becomes x plus y whole square. It becomes x plus y derivative, which is 2x minus x square plus y square. Derivative is 1. If I simplify this one, 2x square, 2xy minus x square minus y square whole divided by x plus y whole square. If I simplify further, then this becomes x square plus 2xy minus y square whole divided by x plus y whole square, which is dou z by dou x. I hope now it is clear how do we calculate the partial derivatives of the functions of u by v. Similarly, we need to calculate the equation 1. We need to calculate the equation 1. What is equation 1? X square plus y square by x plus y. We need to calculate the partial derivative with respect to what? With respect to y. Okay. Equation 1, partial derivative with respect to y, which is dou z by dou y equal to, the denominator becomes what? X plus y whole square, x plus y into partial derivative with respect to y. This becomes x square plus y square minus x square plus y square partial derivative with respect to y, x plus y. This denominator becomes x plus y whole square, x plus y into partial derivative. This becomes 2y minus x square plus y square partial derivative. This becomes 1. Let us take this value. Let us take this value. This value becomes 2xy plus y square minus x square minus y square which is 2x square 2y square divided by x plus y whole square. What happens now? Y square plus 2xy minus x square divided by x plus y whole square, which is dou z by dou x. Now we calculated, these are the standard derivatives now for this function. Okay, for this, now what we will do with this partial derivative with respect to x and with respect to y, we need to verify dou z by dou x minus dou z by dou y value. We need to supply, this is called as LHS, I can say. Therefore, what is the first function? X square plus 2xy minus y square whole divided by x plus y whole square minus of, therefore, y square plus 2xy minus x square whole divided by x plus y whole square. So, take the denominator value. This denominator is constant, x plus y whole square. What happens? X square plus 2xy minus y square. If I open the bracket, minus y square minus 2xy plus x square minus 2xy plus 2xy gets cancelled. The resultant value becomes which is dou z by dou x minus dou z by dou y. The numerator becomes 2x square plus minus 2y square divided by x plus y whole square. If I take the 2 as a common, I can write x plus y into x minus y whole divided by x plus y whole square. If I remove this one, then this becomes 2 into x minus y by x plus y. This is the value of LHS. This is the value of LHS. Further, we need to prove partial derivative for the RHS function. I am going to erase this one. I am going to write RHS part also. What is the RHS value? RHS value is equal to what is RHS value? 4 into 1 minus of dou z by dou x minus dou z by dou y. We need to prove both LHS value is equal to RHS value. Let us take this RHS. What is RHS value? 4 into 1 minus dou z by dou x minus dou z by dou y, which is 4 into 1 minus dou z by dou x. What is dou z by dou x? If I multiply with a negative sign, then this becomes x square minus 2xy plus y square. Again, if I subtract this numerator value, then this becomes minus 2xy minus 2x minus first I'll remove this. Okay, first minus y square minus 2xy plus x square whole divided by, this becomes x plus y whole square. What are the terms are removed now? In this case? Okay, we need to make this as a square. Okay, then this becomes 4 into 1 minus, what are the terms gets cancelled? Minus x square minus, this becomes, there is a bracket. Let us go with this partial derivatives, function. This becomes, if I take this LCM entire value, this becomes x plus y whole square, minus x square and minus y square plus y square. Remaining is, this also gets cancelled. This becomes plus 4xy. This becomes minus 4xy divided by x plus y whole square. If I simplify this one, 4 into x square y square plus 2xy minus 4xy whole divided by x plus y whole square. 4 into this, we can rewrite x square plus y square minus 2xy divided by x plus y whole square. How do you write this one? This becomes 4 into x plus y, 4 into x minus y whole square divided by x plus y whole square. You can write this one, 4 into x minus y, 2 into x minus y by x plus y whole square. If I make the right hand side also, LHS part also this one. Therefore, LHS is equal to RHS. I hope now this is clear about the partial derivatives verification. Whenever there is a function, we can verify both LHS value as well as the RHS value. Let us take one more function. There is a function, also a function of function, which is x plus phi into c plus phi x minus of ct. There is a proof that there is a second order partial derivatives with respect to t, again with respect to x. We need to verify. I think this is a solution of the one heat equation. Z equal to x plus ct plus phi into x minus ct is the solution of the heat equation function. Let's go with this function now. Z, let us take this function x plus c into t plus 5 into x minus ct. Let us take this as equation 1. We need to calculate how many derivatives. If I take z, I need to calculate one x order x derivatives 2 times and t derivatives 2 times. Now we need to verify both LHS value equal to RHS. Okay. Equation 1, partial derivative with respect to x. Then this becomes dou z by dou x. What is dou z by dou x? There is a function, will have a derivatives. Therefore, f dash of x plus c into t, derivative of inner derivative of x becomes 1 plus phi derivative is phi dash, x minus ct, derivative of x becomes 1. Similarly, again partial derivative with respect to x, then this becomes dou z by dou x square equal to f double dash of x plus ct, again 1, this also 1 times 1 is 1, plus similarly phi derivative is becomes phi double dash x minus c into t. This is dou square z by dou x square. Similarly, the equation 1, we need to calculate the partial derivative with respect to t time. Therefore, dou z by dou t, equation 1, partial derivative with respect to t. What happens? Dou z by dou t. Therefore, f dash of x plus ct. See here, when we make the derivative with respect to t, what will be? T becomes 1. There is a occurring constant will be the c. Therefore, plus phi derivative is phi dash x minus ct. Inner derivative of this function is minus c. Similarly, dou square z by dou t square, again one more partial derivative of this function, f double dash x plus c into t, this becomes c square, plus phi double dash of x minus c into t, again it becomes one more minus c. Then this becomes dou z by dou t square is equal to, I can take c as a common, then this becomes f double dash x plus c into t plus minus of c plus c square is gets common, phi double dash of x minus c into t. Therefore, dou square z by dou t square equal to c square into, I can replace this entire quantity by using dou square z by dou x square. Now, this equation becomes dou square z by dou t square, which is equal to c square into dou square z by dou x square. I hope now you enjoyed the partial derivatives of single variable function and two variable function, where these partial derivatives are existed in the real life problems. I hope now this is clear. In the next module, we are going to discuss little more problems about the partial differentiation. Thank you.